All
All right.
right.
So thank you. Thank you for joining us, everyone. Good afternoon. I'm Steve.
And I'm Scott.
Together, we're Backyard Musing. I'm in Apple Valley, People's Republic of California.
Yep. And I'm still at the secret bunker, secret location bunker, Wasatch Front.
No.
And I'll be here for a few days. So
Okay.
here we go.
Very weird subject today, but it's science and technology. Researchers have traced how sperm rapidly shift from a dormant to an energy charged state during their journey to fertilize an egg. Researchers at Michigan State University have identified a molecular switch that boosts sperm energy during their final push to reach an egg. This breakthrough could transform how infertility is treated and open the door to new non-hormonal options for male contraception. Would you like to know more?
And if you're asking yourself right now, if you heard Steve right, you did. He said sperm. Okay. Sperm metabolism is special since it's only focused on generating more energy to achieve a single goal, fertilization.
It's special.
Yep. This is according to Melanie Ballbach, an assistant professor in the Department of Biochemistry and Molecular Biology and senior author of the paper. Okay.
Michigan State Spartans. Okay, before ejaculation, sperm in mammals remain in a low energy, inactive state. Once released, they begin their journey through the female reproductive tract, where they experience a series of transformations that prepare them for fertilization. These changes include faster, more powerful swimming motions and modifications to the membranes that will eventually come into contact with the egg.
This is a quote. Many types of cells undergo this rapid switch from low to high energy states, and sperm are an ideal way to study such metabolic reprogramming, says Ballbach, who in 2023 brought her pioneering science on sperm metabolism to MSU. I wonder where she brought it from. Did she get kicked out of another school because they didn't want to talk about it?
But you can liken this to like paratroopers. Paratroopers are on that plane. They're just in a dormant state, waiting to where they got to go to their drop point. So they're just waiting, sometimes sleeping. And then all of a sudden they got to get up on the ready line. They have to hook up. They shuffle to the door and then they jump out to get to the ground.
They're waiting for the order from their captain.
That's right. There's going to be a lot of metaphors on this one. As a postdoctoral researcher at Weill Cornell Medicine, Ballbach drove there. She was from Weill Cornell. Ballbach drove the headline-making discovery that the inhibition of a crucial sperm enzyme rendered mice temporarily infertile.
How did mice get into this article?
Hey, just be grateful it's not beagles. This breakthrough raised Fauci's beagles. Raise the exciting potential for a non-hormonal male birth control. Very exciting.
Metabolism is similarly essential for sperm function. And while scientists knew that behavioral changes prior to fertilization required a large amount of energy, they weren't sure how sperm adjusted to meet the demand until now.
And this might explain how that large amount of energy makes the captain so exhausted afterwards, just collapsing and falling asleep. This might explain it.
One and done. This is a one and done mission.
Teaming up with scientists at Memorial Sloan. Well, if you've ever been in a spot where you've collapsed and then you feel a slap on your cheek, you're not done. Get up. Don't go to sleep. Teaming up with scientists at Memorial Sloan Kettering Cancer Center and the Van Andel Institute, Ballbach's group created a special, I just caught that, Ballbach's group created a special technique that allowed them to track the metabolism of glucose, which sperm take up from their environment and use as a sort of fuel.
By tracing the chemical journey of glucose within sperm, they observed key differences between dormant and active specimens. Quote, you can think of this approach like painting the roof. Now, I didn't get this one. Painting the roof of a car bright pink and then following that car through traffic using a drone. Ballbach explained.
Yeah, it's like tracking the chemical, I guess.
Yeah, whatever.
But pink, what? I mean, is that a metaphor right there?
I don't
Okay.
know.
Quote, in activated sperm, we saw this painted car moving much faster through traffic while preferring a distinct route and could even see what intersections the car tended to get stuck at, she said. She added.
Yeah. I didn't know we were going to have this much fun talking about this. So, by leveraging facilities such as MSU's mass spectrometry and metabolomics core.
Yeah, sound it out. Yep.
Okay, I'm sounding it out. Thanks. Thanks for your patience. The study paints a fuller picture of the high energy, multi-step process required for sperm to reach their goal of fertilization. This includes the discovery that a particular enzyme called adolase
Yeah.
helps sperm convert glucose into energy, and that sperm I've never used this word that much ever, even utilize molecular fuel that they already have on board when they begin their trek. So they got extra oomph, I guess, extra fuel.
Yeah, they got that food stores that boom, they can get that energy going.
Okay.
Makes sense.
The experiments also revealed how some enzymes regulate the flow of glucose like traffic controllers. I don't follow that either, but whatever.
Looking ahead, Ballbach will continue to explore how sperm use a variety of fuel sources like glucose and fructose. Oh, what's going on?
Oh, I was going to say that's not my fault.
To meet their energy needs. This research can potentially impact a number of reproductive health issues.
With 1 in 6 individuals, in fact, impacted by infertility globally, that's a lot.
Yeah.
Ballbach sees the analysis of sperm metabolism as an especially promising research direction for improving both assisted fertility techniques and the diagnosis of infertility in patients. This work can also help develop new methods of contraception like non-hormonal birth control. Okay.
Quote, better understanding the metabolism of glucose during sperm activation was an important first step. And now we're aiming to understand how our findings translate to other species, like human sperm, Ballbach said. Continuing the quote, one option is to explore if one of your traffic control enzymes could be safely targeted as a non-hormonal male or female contraceptive, she added.
The traditional development of male contraceptives has focused on blocking sperm at their creation. This approach, however, comes with notable drawbacks. The process of becoming infertile is far from on demand, and such contraceptives are commonly hormone-based, leading to many severe side effects. Well, yeah, we don't want that.
Yeah, like glow in the dark eyes.
Yeah,
the latest findings from Ballbach and their collaborators are paving the way for a sperm metabolism-centered solution to these changes, an inhibitor-based, non-hormonal method of contraception that will allow for on-demand male infertility with little to no side effects. Quote, right now, about 50% of all pregnancies are unplanned, and this would give men additional options and agency in their fertility, Ballbach said. Likewise, it creates freedom for those using female birth control, which is hormone-based and highly prone to side effects. I wouldn't know anything about that.
Well, yeah, we don't like side effects in anything.
Right.
So,
right.
Especially when you're talking about, the internal organs of a male or female's body. So not good. But anyway, interesting article.
Very interesting.
I'm glad we got through it.
Yeah, I know. All right. We'll see you tomorrow.
All right.
Until then.
Have a good night. Thank you.
Yep.
Okay. So